Hello and welcome ProITians. So in this session we are going to look at application delivery service, right? But till now we have covered all the possible options that application protection service provides in Azure, right? Now with this session we are going to talk on the various components of Azure Delivery Service, right? We're going to start with our sessions on content delivery network, and we'll see why it is required and what are the benefits that we can get out of content delivery network. Then we'll move on to Azure Door Services, where we are going to look on the other components of the Azure Door Services, and then we are going to move on to see the Azure Gateway or Application Gateway Service, and we're going to look at all these components in detail in the session, right? Great. Before I move to the session, I would request you to please click on the subscribe icon and do click on the bell icon so that you can get notifications as soon as I upload all these videos, right? Also, do click on the like button and feel free to share this video with your friends and colleagues, because I believe educations like these should be made free of cost. All right, great. Thank you all, and I'll see you in the session. Welcome back, ProITians. So in the earlier sessions we have covered about the application network protection service, and now what we are going to do is we are going to cover about application delivery service, yeah, and we are going to see what are the various components that are part of your application delivery service that helps in providing the application delivery to the end user, right? Before I begin, all images and the contents that I've taken are actually from the Microsoft portal. Yeah, just want to give them a credit for the beautiful work, the nice work that Microsoft has been doing. Right, great. Let's get started. So, one of the first component that actually is part of the application delivery service is content delivery network. A content delivery network is a distributed network of servers that can efficiently deliver web contents to users. Content delivery network, or CDN, which is actually in short it is referred to CDN. So CDN stores cached content on edge servers in point of presence locations that are close to end users to minimize latency. Yeah. And these are the benefits of the content delivery network. Yeah. Before I move to the benefits, let me also give one more pointer on the content delivery network. So CDN offers developers a global solution for rapidly delivering high bandwidth content to users by caching their content at strategically placed physical nodes across the world. Be it whatever sites, all these global sites, they will have the plan for the content delivery network, and that's how it's actually cached to the edge delivery location, and then it actually becomes very easy for the users to get all those updates or get all those cached information without having to cause any latency issues, right? Azure CDN can also accelerate dynamic content which cannot be cached by leveraging various network optimization using CDN POPs. For example, route optimization to bypass BGP protocol. Yeah, great. Now let's move on to the benefits of CDN. So what are the benefits that CDN can provide? It can provide better performance and improved user experience for end users, especially when using applications in which multiple rounds or multiple trips are required to load content. Yeah, large scaling to better handle instantaneous high loads, such as the start of the product launch event. Yeah, you can that is one of the great example to use CDN. Distribution of user networks and serving of content directly from edge server so that less traffic is sent to the original server. Yeah, so that's how we can actually these are the benefits that CDN can provide to reduce the latency. Yeah, now this is how it works actually. Yeah, a user, let's take an example. An IaaS actually would request a file by using a URL from the special domain name such as uh, xyz.com. This name can be part of your Edge host name or a custom domain, right? The DNS routes the request to the best performing POP or the point of presence. Yeah. If no Edge servers in the POP have the file in their cache, the POP requests the file from the origin server. The origin server can be an Azure web app, Azure cloud service, Azure storage account, or any publicly accessible web service. Yeah. So then the origin server returns the file to the Edge server in the POP. Yeah. And Edge server in the POP caches the file and returns to the original request alias. Yeah. The file remains cached on the Edge server in POP until the TTL specified by its HTTP headers configuration. If the origin server didn't specify a TTL default, TTL is 7 days. Okay. Now what happens is when an additional user can request the file, then again it follows the same process. But this time the file is present in your Edge server. So this time it doesn't need to go to the origin server. It can actually get it delivered to the user from the Edge servers. Yeah. So that is how it actually works. I mean, you can have so that's how we can have all these placed across the geographical location, so that all the users can get this information which is close to their location. Yeah, great. Now let's talk about the requirements and limitations. Yeah. So requirements, to use Azure CDN you must own at least one Azure subscription. You also need to create at least one CDN profile, which is a collection of CDN endpoints. Every CDN endpoint represents a specific configuration of content, deliver, behavior, and access. To organize your CDN endpoints by internal domain, web applications, or some other criteria, you can use multiple profiles. Because Azure CDN pricing is applied at the CDN profile level, you must create multiple CDN profiles if you want to use a mix of pricing tiers. Now let's talk about the limitations. Each Azure subscription has default limits for the following resources. It has a default number of CDN profiles that can be created, a default number of endpoints that can be created in CDN profile, and the default number of custom domains that can be mapped to an endpoint. Alright, now let's move to the next service that helps in providing the application delivery service, that is called as Azure Front Door. Yeah, so Azure Front Door enables you to define, manage, and monitor the global routing for your web traffic by optimizing for best performance and quick global failover for high availability. With Front Door, you can transform your global, that is multi-region, consumer, and enterprise application into robust, high performance, personalized modern applications, APIs, and content that reaches a global audience with Azure. Front Door works at layer 7 or HTTP or HTTPS layers and uses any CaaS protocol with split TCP and Microsoft's global network, that is the backbone network for improving global connectivity. So per your routing method selection in the configuration, you can ensure that the Front Door is routing your client requests to the faster and most available application backend. An application backend is an internet-facing service hosted inside or outside of Azure. Front Door provides a range of traffic routing methods and backend health monitoring options to suit different application needs and automatic failover modules. It's actually similar to your traffic manager. Front Door is resilient to failures, including the failure of an entire Azure region. A traffic manager is another concept of application delivery service, which we are going to look in the coming slides. All right. Now let's move to the next one. Let's talk about the application delivery. Azure Front Door features. So it provides accelerate application performance, So it uses a split TCP based anycast protocol, right? I mean, which you have seen in the last slide. Front door ensures that your end users promptly connect to the nearest front door point of presence, using Microsoft's global network for connecting to your application backends from front door POPs, and ensure high availability and reliability while maintaining performance. This connectivity to the backend is also based on based on the least network latency. All right. Increase application availability with smart health probes. So, what does that mean? I mean, so Front Door delivers high availability for your critical applications using its smart health probes, monitoring your backend for both latency and availability, and providing quick automatic failover when a backend goes down. So you can run plant maintenance operations on your applications without downtime. Front Door direct traffic to attractive alternative backends while the maintenance is in progress. All right. Next one is URL based routing. So URL path based routing allows you to route traffic to backend pools based on URL paths of the request. One of the scenarios is to route requests for different content types to a different backend pool. For example, request for www.xyz.com/users/star are routed to a user profile pool, whereas www.xyz.com/products/star are routed to product inventory pool, right? So Front Door allows even more complex route matching scenarios using best math algorithm, and so if none of the path patterns match, then your default routing for the rule will be xyz.com/star. All right, great. Multiple site hosting. Multiple site hosting enables you to configure more than one website on the same Front Door configuration. This feature allows you to configure more efficient topology for your deployments by adding different websites to a single Front Door configuration. Based on your application's architecture, you can configure Azure Front Door to direct traffic to your backend pool, or have various websites directed to the same backend pool. For example, Front Door can serve traffic for images.xyz.com and videos.xyz.com from two different backend pools called image pool and video pool, right? So you can actually distribute the load accordingly. And alternatively, you can configure both the front-end hosts to direct traffic to the single backend pool. Yeah, great. Now let's talk about session affinity. So a cookie-based session affinity feature is useful when you want to keep a user session on the same application backend, right? By using Front Door managed cookies, subsequent traffic from a user session gets directed to the same application backend for processing. This feature is important in cases where session state is saved locally. TLS termination. So Front Door supports TLS termination at the edge, that is, individual users can set up a TLS connection with the Front Door environments instead of establishing it over long haul connections with the application backend. Additionally, Front Door supports both HTTP as well as HTTPS connectivity between Front Door environments and your backends. So you can also set up end-to-end TLS encryption. Yeah. For example, if a Front Door for your application workload receives your 5,000 requests in a minute due to warm connection reuse for the active services, it will only establish about 500 connections with your application backend, thereby reducing significant load from your backends. Custom domains and certificate management. When you use Front Door to deliver content, a custom domain is necessary if you would like your own domain name to be visible in your Front Door URL. Having a visible domain name can be convenient for your customer and useful for branding purposes. Front Door also supports HTTPS for domain names, And you should use this feature by either choosing Front Door Manage Certificates for your traffic or uploading your own custom TLS or SSL certificate. Application layer security. So Azure Front Door allows you to author custom web application firewall, that is WAF, which we had seen in the previous sessions. And web is used for access control to protect your HTTPS and HTTP workloads from exploitation based on client IP address, country code, or HTTP parameters. Right. So Front Door platform itself is protected by Azure DDoS protection basic. For further protection, Azure DDoS protection standard may be enabled at your VNet and safeguard resources from network layer TCP UDP attacks. And just to note, Front Door is a layer 7 reverse proxy, so it only allows web traffic to pass through to backends and block other types of traffic by default. URL redirection. With a strong industry push on supporting only secure communication, web applications are expected to automatically redirect any HTTP traffic to HTTPS, correct? So this ensures that all communication between the users and the application occurs over an encrypted path. Traditionally, application owners have dealt with this requirement by creating a dedicated service whose sole purpose was to redirect requests if it receives on HTTPS to HTTP to HTTPS. Azure Front Door supports the ability to redirect traffic from HTTP to HTTPS. This simplifies application configuration, optimizes the resource usage, and supports new redirection scenarios, including global and path-based redirection. URL redirection from Azure Front Door is not limited to HTTP redirection alone, but also to redirect to a different hostname or even a different path. Alright. URL rewrite. Front Door supports URL rewrite by allowing you to configure an additional or optional custom forwarding path to use when constructing the request to forward to the backend. Front Door further allows you to configure host headers to be sent when forwarding the request to your backend. Right. So these are some of the features that Azure Front Door provides. Right. Now let's move to the next one, that is Azure Traffic Manager. So Azure Traffic Manager is a DNS based traffic load balancer. It enables to distinguish traffic optimally to services across global Azure regions while providing high availability and responsiveness. Traffic Manager provides a range of traffic routing methods to distribute traffic such as priority, weight, performance, geographic, multi-value, or subnets. Now let's look at this and walk through the this particular diagram. So what happens is, for example, you have this traffic, right? I mean, when the traffic is coming, it actually goes to the Traffic Manager. Now Traffic Manager will have an inventory of what is present and how is the state of each region. So you have a primary region which is on priority 1, failover region which is on priority 2 and 3, correct? Now it will have this sort of inventory of the status, right? So when a traffic comes in, a Traffic Manager will intelligently direct the traffic to the next available sites. So that the clients can directly connect to the selected endpoint, and that would not actually go to the Traffic Manager. So Traffic Manager will update this information to the client directly. Right? Great. Now let's look at the load balancer. So Azure Load Balancer provides high performance, low latency, layer 4 load balancing for all UDP and TCP protocol. It manages inbound and outbound connections. It can be configured for public and internal load balanced endpoints. And rules can be defined to map inbound connections to backend pool destinations by using TCP and HTTP health probing options to manage service availability. So you can have this sort of these are your external or your public facing load balancer and your internal load balancer. Yeah, so whatever traffic is coming in, it will actually redirect the traffic to the available virtual machines, and it does the health proving things to make sure that it is going to direct the traffic to the available virtual machine or an available application. All right, let's move to the next one, that is application gateway. So Azure Application Gateway is a web traffic load balancer that enables you to manage traffic to your web applications. It is an application delivery controller as a service, or ADC as a service. Yeah, it offers various layer 7 load balancing capabilities for your application. An application gateway can make routing decisions based on additional attributes of an HTTP request. Yeah, for example, a URI path or a host header, you can route traffic based on the incoming URL. Yeah, so if images / images is in the incoming URL, you can route traffic to the specific set of servers. Yeah, or to the pool of servers configured for images, and similarly for /videos to a videos pool. Yeah, great. So this is how it works. Yeah, so you have this user and the traffic, which is it will actually check the traffic, and if the URL is based for the images, it will direct the traffic for images, and for videos it will direct the traffic to the videos pool. All right, it's a layer 7 load balancer. Yeah, great. So we have covered quite a bit on this session, and that's covering all the features that are available with application delivery service, right? But in case if you want to have some more information, you can visit to these links and get more information on them. Yeah, that's all guys for this session, and please do subscribe to the channel and click on the bell icon to get real-time updates, and also please like the videos and feel free to share the videos to your friends and colleagues so that they can also enjoy these free sessions, right? Great. Until next time, keep watching and keep learning. Thank you.